Well, this is exercise 9A.1. We're going to have at least 2 goes, possibly 3 goes at doing exercise 9A because there's quite a lot of work in it. And we're going to look at Pascal's triangle and binomial expansions. And this is Blaise Pascal, French mathematician, who did a lot of work on probability. And this, what he did on this, led to work on algebra as well, and vice versa. So Blaise Pascal, very famous French mathematician, who we're going to look at some of the work that he did. Now, some of it is fairly obvious now looking back. So, for instance, he looked at what were called binomial expressions, and a binomial expression is 2 things in a bracket, as far as we're concerned. So it might say, for instance, x plus y. And we then do something to it, and normally we raise this to some power, so to the power 4. So you'll notice I've got 2 expressions here, and one of them is 1 plus 4x squared, and 1 plus 4x cubed. So I just want you to multiply them out. So I'm going to do it now. You might want to pause the video and do it yourself. So that's 1 plus 4x squared, and that gives me 1 plus, what's that, 4x, and 4x is 8x. Plus 16x squared. And if I do it again, well, so the good news is some of this work is already done for me, because 1 plus 4x cubed is the same as 1 plus 4x times 1 plus 4x squared. So I can effectively shortcut this and just write it like this. And then there's certainly less repetition involved. And 1 times 1 is 1. Plus 8x plus 16x squared, that bit was easy. And now I'll do the 4 times all of these things. 4x plus 32x squared plus 64x cubed. And now I tidy up a bit. And it says in ascending power, so it basically means you start with your 1 first of all. How many x have I got? Plus 12x. Plus 48x squared and just the 64x cubed. So I've done it. And hopefully you've done it already as well. And I've got the right answers. Powers of A plus B then. So basically this is what Pascal looked at. He looked at the simple one. Binomial expansion, then we're going to have 2 parts to it. And as we've just seen, A plus B squared. Well, it won't surprise you to learn that this is A plus B times A plus B. And a lot of people go wrong on these because they just square this one, they square this one. But of course you end up with A squared plus an AB plus another AB plus a B squared. And here's my simplified answer. I put 2AB in the middle. And the important thing about this is you've got 1 of these, you've got 2 of these, and you've got 1 of these. That might seem trivial at the moment, but that turns out to be quite important. Now, A plus B cubed, again, I can cheat a bit because I know that A plus B cubed is A plus B times by A plus B squared, and I already know that answer because I wrote it down just now. A plus B times by A squared plus 2AB plus B squared. So when I multiply this out, I get A cubed plus 2A squared B plus AB squared, and now switch to the B plus, well, BA squared, but that's, you can see that's the same as that, so I'm going to put it alphabetically so it makes more sense, plus A squared B plus 2, and I wrote AB squared last time, so I'm going to write AB squared here plus a B cubed. Now if you just look at that quickly, you say you've got an A cubed, you've got 2 of these and another one, so that's 3A squared B. You've got 1 of these and 2 more, so that's 3AB squared plus B cubed. Now let's just look at this again. Notice the A's. It goes A cubed, A squared, A, and then there's none of them. Whereas the B's, there's no B's, then there is a B, then there's 2 B squared, then there's B cubed. And then again, the coefficients I want you to look at are 1, 3, 3, 1. Remember last time the numbers were 1, 2, 1, so it begs the question, what would happen if I do A plus B times 4? And that's quite a reasonable question, and you might have some views as to what this is. If I do A plus B, well, again, I can shortcut this. Just now I found out that A plus a plus b all cubed, I found an answer to that. So if I do a plus b times a plus b all cubed, it'll give me a plus b to the 4, which is obviously a lot quicker. So this was a cubed plus 3a squared b. Notice, as I said, the powers go down on the a. And then it was ab squared, and then you end up with no a's at all. So if I multiply out these, multiply them all by a, plus 3a squared b squared plus ab cubed. Now times them all by the b. Now again, that's an a cubed b. I'm going to always write them alphabetically. What's that? Plus 3a squared b squared plus that's a b to the 4, I think. 1, 2, 3, 4, 5, 6, 7. I've got enough terms. ba cubed. I should have 8, I think. 1, 2, 3, 4. Plus a cubed b. Plus 3 of those. The one I missed out is that one. So let's just slide this in now. That's a 3ab cubed plus b to the 4. And I knew I'd done something wrong there. So if I tidy this up, I get an a to the 4. You'll notice I've got 3a cubed b, and I think I should have another one. Yes, I have. It's 4a cubed b. And then I've got a squared b squared. I've got 3 of them there. And I've got another 3 of them there. I've got 6a squared b squared. I've got ab cubed plus another 3ab cubed. That's 4a cubed b. Sorry. ab cubed, nearly got it wrong again, plus b to the 4. These are hard enough as they are without me making daft mistakes. And so my answers, when I did it, are the same as those. And I suppose the important thing there is to notice is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Are they the coefficients you were expecting? Or did you think maybe 1, 4, 4? 4, 1. It's the surprise number there is the 6 in the middle. And if I just put these into a table, they start to make a bit more sense. When it was a plus b squared, it was 1, 2, 1. When it was a plus b cubed, it was 1, 3, 3, 1. This was the surprise, 1, 4, 6, 4, 1. And you can do the top two lines as well. They are actually a lot fairly straightforward as well, and I'll just put those in. Obviously a plus b to the 1, anything to the 1 you can ignore, so it's a plus b. There's an a, there's a b, and a plus b to the 0, anything to the 0 is a 1. So that was just a 1. This is Pascal's triangle. Named after the French mathematician, as I mentioned before. And interestingly, these numbers can be found using your NCR button. You type in, say I want this number here. I'll do this number here. This number, a bit annoyingly, this is the 0th number, first number, second number, third number, even though it's that 1, 2, 3, 4th actual number. And which row are we in? We're in the row that it's got a 4 in it, a 4 in it. So we would call that 4C3. And type 4C3 and you get 4, as it predicts you would. So these are on our calculator, on the NCR button, but I very often just draw out the table. They come in very useful. So let me show you how they come in useful. Sometimes you want to expand 2 plus x to the 5. So 2 plus x to the 5. I am going to use my knowledge of the powers going down for one of the numbers and going up for the other one. So this is equal to, now because it's to the 5, I look in the 5th row, and these are the numbers I'm going to end up using in this question. So what have I got? I've got 1 times by 1 because of this one here, 2 I'll put to the power of 5, and x I put to the power of 0. Later on I won't even bother writing that. My next number, it says, is 5. So I'm going to write 5 times by 2. Now notice the 5 drops to a 4, and notice the x goes up to a 1. Next number is a 10. Plus 10 times by 2 to the 3, it drops down 1, times by x to the 2, it's gone up by 1, plus 10. times by 2 to the 2 times by x, not squared now, it was squared, now it's 3. One thing you can always do is look at the powers. 2 and 3 make 5, which was the top power. 3 and 2 make 5. 4 and 1 make 5. 5 and 0 make 5. The powers will always add to 5 in this example. Next one's 5 times 2 to the 1 times x to the 4. Notice the 2's have gone down, the x has gone up. Plus 1 times by 2 to the 0 times by x to the 5. For this job I've got to simplify it. This gives me 32. Notice x to the 0's disappear. 2 to the 4 is 16, times by 5 is 80. X. 8, 2 cubed is 8, times by 10 is 8e. X squared. 10 times 2 squared, I reckon, is 40, x cubed. 5 times 2 to 1 is 10, x to the 4. And the last one is just x to the 5. That is the answer I wanted. So this is what you need to be able to do. Here's another one. Oh, if you ever get a minus, just be aware the answers won't go plus, 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 plus. They'll go plus, minus, plus, minus. So notice it's to the 5 again, so I'm using the same numbers. So it says write this out. So let's do it. 3 minus 2x to the 5. And if I'm doing this, I do 1 times by the first number to the 5 times by the second number. Notice I'm writing minus 2x. Actually, I don't need to worry about the minus because I'm going to take care of that somewhere else. To the 0. This next one I know will be a minus. Remember what I said? If it's a minus in the middle, I'll go plus, minus, plus, minus. So I will get 5 times by 5 because of this number here. 3 to the 4 times by 2x to the 1. Plus, plus, minus, plus. Next number is a 10 times by 3 cubed times by 2x squared. Minus, plus, minus, plus, minus. 10 times by 3 squared times by 2x cubed. And notice I put that in brackets. Plus 5 times by 3 to the 1 times by 2x to the 4. Plus 1 times by 3 to the 0 times by 2x to the 5. Let's simplify. 3 to the 5, I think it's 243. Should know that, but I'll better check. 3 to the power of 5, 243 was right. And the 2x to the 0 disappears. Minus, well, it's 5 times 81. Now notice times by this too. So I'm going to do 5 times 81, that's the 3 to the 4, times by 2. 810, that's a big old number. 810x to the 1, which I'm not going to bother with, plus 10 times by 3 cubed is 27, so I'm typing in 10 times by 27. Now notice this is where people always go wrong. It's 2 squared. So I've got to times by 2 squared, and I get 1080. That's where people are going to go wrong, if they're going to go wrong at all, x squared. Minus 10 times by 3 squared, well that's 10 times by 9, times by, don't forget, it's 2 cubed. Now, if I times by 2 cubed, I get 720. So that's 720 x cubed. 5 times by 3 is 15, times by 2 to the 4 is 16. I get 240 of those. Notice it's going plus, minus still. And 2 to the 5 is 32, so minus 32x to the 5. Is that pretty? No, well, not very, is it? I want us to practice this in class. Now there's one example which I'll say for class, it's one of the ones with fractions in, and they can cause us a few problems as well, but I'll save it in class, so I'll go through that in lesson. And for now that will do. This is in our job for the first part of this lesson is to have a look at exercise 9A. We may well do more than just question 2, but we'll definitely be coming back for more than one lesson on this. Cheers, thanks.